Welcome to our series on Industrial IoT Data Streaming. I'm Kudzai Manditereza, and in this video you will learn what Industrial IoT Data Streaming is, why it matters, and the key steps to get started with it. Let's begin by understanding the current challenges facing industrial enterprises. Industrial organizations face a critical challenge today, which is the inability to access and act upon operational data in real time. This is due to three primary limitations of traditional manufacturing data architectures. First, there is the data latency. Data collection occurs through batch processing, typically on a daily or shift-based cycles. This creates a fundamental disconnect between when events occur and when they become visible to decision makers. Second, there is system fragmentation. Manufacturing enterprises typically operate with disparate systems, ERP, MES, SCADA, and PLC systems that communicate through point-to-point integrations, creating what we term as the spaghetti architecture. Third, there is limited scalability. As operations expand, these custom integrations become exponentially complex, resulting in a technical debt that impedes innovation and agility. These limitations result in reactive operations management, where problems are addressed after occurrence rather than prevented through predictive intervention. Industrial IoT data streaming represents a paradigm shift in manufacturing data management. It is the continuous, real-time transmission and processing of data from industrial assets, sensors, and systems across a manufacturing enterprise, utilizing event-driven architecture to enable immediate insight and action. The foundational technology enabling this transformation is the MQTT protocol, which operates on a publish-subscribe pattern. The protocol, specifically designed for industrial applications, provides three critical capabilities. First, low latency communication. MQTT architecture allows you to stream data in real time rather than waiting for end-of-shift reports. Second, decoupled architecture. Systems in an MQTT network operate independently while maintaining data synchronization. And third, guaranteed delivery. MQTT's built-in quality of service ensures no data loss even during network interruptions. The architecture centers on an MQTT broker, which serves as a central nervous system for the manufacturing enterprise. Data producers, which include sensors, machines, and systems, publish events to specific topics. And data consumers, which could be analytics platforms, control systems, and business applications, subscribe to relevant topics and receive updates instantaneously. To fully appreciate the transformational nature of streaming architecture, let's conduct a systematic comparison with traditional approaches. In conventional systems, data flow follows a request-response or batch transfer model. In this approach, systems like ERP, MES, SCADA, and historians communicate through custom-built, isolated connections or nightly data exchanges. This results in a tightly coupled architecture that's difficult to manage, scale, and adapt. This complexity leads to limited data availability, long lead times when integrating new assets, and high maintenance efforts, making it hard to innovate or respond to quality issues. The result is a fragmented data environment with siloed visibility. Real-time machine data, operator actions, and quality checks often fail to reach decision makers in time to prevent downtime or inefficiencies. In contrast, an industrial IoT data streaming architecture operates on an event-driven model. For example, sensor readings on the shop floor are published to the MQTT broker whenever a change of state is detected, and then multiple systems subscribe to this stream simultaneously. Predictive maintenance algorithms analyze patterns in real time. Quality systems correlate temperature with product specifications. The MES updates production schedules based on equipment status. Cloud analytics platforms aggregate data for enterprise-wide optimization. This parallel real-time processing enables what we call concurrent intelligence, where multiple systems deriving insights and taking action on the same data simultaneously. Now let's examine four critical applications where industrial IoT data streaming delivers measurable value. In predictive maintenance, streaming architectures enable continuous monitoring of equipment health indicators such as vibration, temperature, pressure, and electrical signatures. Machine learning models process these streams to identify the degradation patterns before failure occurs. In real-time quality assurance, quality control transforms from sample-based inspection to 100% real-time verification. Computer vision systems stream image data through quality algorithms that identify defects within milliseconds. Parameters can be adjusted mid-production, preventing entire batches from falling outside specifications. In supply chain orchestration, material consumption events trigger automatic replenishment workflows. When inventory levels cross predetermined thresholds, the system generates purchase orders, schedules deliveries, and updates production planning systems, all without human intervention. And in multi-site production balancing for organizations with distributed manufacturing, streaming enables real-time load balancing across facilities. When one plant experiences disruption, production automatically shifts to alternate sites, maintaining customer commitments while minimizing operational impact. Beyond immediate operational gains, streaming architectures provide scalability, which enables linear scaling from pilot implementations to enterprise-wide deployment. Flexibility, whereby new use cases can be added without disrupting existing systems. Innovation enablement, by enabling you to build a foundation for artificial intelligence and machine learning initiatives. And competitive differentiation, because of real-time responsiveness, which becomes a market advantage. So as you consider implementing industrial IoT data streaming in your organization, remember that this represents more than just a technical upgrade. It's a strategic transformation that positions your company for Industry 4.0 readiness. In the next video, we'll dive into how to build an industrial IoT data streaming architecture with MQTT. Thank you for watching, and don't forget to like, share, and subscribe.